Hello and welcome. So today we're going to be talking about loops. We are talking about iteration repeating slash looping, all the same thing, the same concept. If we want to repeat a certain section of code any number of times, you probably want to use a loop for it rather than just copying and pasting code. It's way more efficient for doing that. Now, there are three main types of loops that we'll be covering. A few subtypes in there, but we'll just talk about these for now. So first is a while loop. We'll be looking at that first and foremost. It's the main focus of this video, and it's most useful for an indefinite number of loops. So what I mean by that is you don't know exactly the number of times you need to loop through and repeat this code, but you know an expression that will tell you if you need to loop again. Then we have a do while. This is what we would call a post-test loop, while the while is a pre-test loop. Important to take note of that. Pre-test versus post-test, and that'll make sense when we go to the next slide. So do while basically just executes the body of the loop, then tests for if it should continue looping or not. So you're guaranteed to get at least one iteration out of a do while loop, whereas a while loop, you are not guaranteed any iterations um, based on the expression. So next we have the for loop. For loop is probably the number one most used loop in general for programming, because it's most useful for when you know how many times you want to loop. So you can say for 1 to 5, let's output hello, and then that will output hello 5 times. So that's the most used case for looping, is just saying I need to do something 5 times, so let's do it 5 times. You throw that into a for loop. Now, let's look at the basic anatomy of a loop before we start looking at the actual code. So this is very important to write this down and commit this to memory, and it is the 3 steps for a loop, or the basic structure of it. So first we have to initialize the loop control variable. This is the variable that's going to determine if we need to go back through the loop another time, or if we're done and we can quit. So that's what we would call the LCV. So we need to initialize that first. Next, we evaluate the expression. So we're checking, does this expression, is it true? And we need to go into the loop. If it's false, we don't go into the loop, so we exit. The third thing is we need to modify that LCV. If the LCV is set to some expression that's true, and we never modify that truth value, then we'll be stuck in an infinite loop, and it'll just constantly do that loop action until the program crashes, which inevitably it will, or it'll lock up your whole computer. Either way, it's not a good thing, so don't forget modify LCV step. Now, let's look at an example of a while loop. This is an example where we are trying to do, like, we're just trying to count to 5. Not the most appropriate use for a while loop, but it's a good example at least, because here's our LCV int number equals 0. This is our loop control variable, because based on what's in number, we can see here in our while and then the open parentheses, this is an expression. This expression, if it evaluates to true, we do the body of the loop. So everything that's between the two curly braces, we execute. Now, what this is going to do when we step through it, int number equals 0. Okay, while 0 is less than 5. That is true. So we enter the loop. So notice it does the check first, then enters the loop. Now we see out I love to code, new line, and then number plus plus. And if you don't remember, plus plus is the increment operator, so it's going to take number plus 1. So number is now 1. We go back to the top of the loop, number is 1. 1 is less than 5. Step into the loop, see out, I love to code, number plus plus, so number is now 2. 2 is still less than 5. We output the statement again, number plus plus, 3, 4, and then now the number becomes 5. Now when the number becomes 5, we come back up to the top. Is 5 less than 5? That is false. Since that is false, we go out and around the curly braces and we continue on with the rest of the program. So what we just did was we wrote this statement 5 times to the screen. So going back to our anatomy of a loop, this is initializing the LCV, int number equals 0. Evaluating the expression is number less than 5. This is the expression that we evaluate first. Then we modify the LCV. What happens here with the cout statement, irrelevant to the loop. It's something that the user wants to do, but it's irrelevant to the loop itself. But we have to modify number, and we have to increment it. We have to get it closer to exiting the loop. Think about if we commented out the number plus plus here. Number would be 0. We would see out I love to code. And then we'd go back to the top and we'd say, is 0 less than 5? That's still true. And we would see out I love to code again. And we would continuously loop forever. We would be stuck in an infinite loop. And that's not a good thing. That's something that we definitely want to avoid if possible. Okay, so a do-while loop. Simple bit of code here. I just wanted to show what it looks like. You're not going to use these that often. You should know how to write one. And you'll notice that there's something a little bit different about it. And it is you put a do, open parentheses, close parentheses, or curly brace, close curly brace. Your body of the loop goes here. And then you have while and your expression here. And then a semicolon. Don't forget the semicolon here. If we go back, you'll notice that there is no semicolon for the while. There's no semicolon here. And there's no semicolon at the end of our curly brace. There just isn't one. In the do while, don't let that trip you up. There is a semicolon at the end of the while here. So this is a post-test loop. Going back again, this is a pre-test loop. So what that means is before we enter the loop and execute what's inside the body of the loop, we have to test the expression. Pre-test. Now going back over here to the do while, it's a post-test loop. What that means is we're going to execute the body of the loop, get down here, evaluate the expression, and if this expression is true, then we go back to the top of the loop and execute the body again. So if we look back here, let's pretend that int number equals 5 is the initializing the LCV. When we get here, we're going to say, is 5 less than 5? That's false. We just went around the whole loop. We didn't execute the loop statement once, the loop body even one time. Now, if we had the exact same setup, but in a do-while loop, we're guaranteed that we're going to do it at least one time. The while may be false and may not loop us back around, but we're guaranteed to execute the body of the loop once. All right, and the last one that we're going to talk about, and probably the most used one, but also a little bit more complicated, is the for loop. Now, the for loop, programmers are lazy, and this is a really good thing here, because you noticed in the while loop, we had to, if I go back, we had to initialize the LCV here, we had to evaluate the expression here, and we had to modify the LCV down here. That's 3 different places where we had to put code. Now if I go back to the for loop, all 3 of those things are happening up here. Now, let me explain exactly what's going on. This first expression before the semicolon is initializing the LCV. Int I equals 0. Now, before I go on, let me just say that in for loops, it's generally okay to use I, J, K, so on and so forth. I actually don't know the origination of starting with a loop control variable with I, but we generally do it in for loops, and it's an accepted practice. Okay, so int I equals 0, that's initializing the LCV. So we're saying I equals 0, and then the next statement is our test expression. So we say is 0 less than 5. That is true. So then we go into the loop and we execute this cout statement, cout 0, and a new line. Then this last statement in the for is your modify LCV. It happens at the bottom of the loop, just like we had set up in our while statement. Just like that. So once we execute the C out, C++ will go back up here, execute the I++, so I becomes 1, and then it will jump back to I is less than 5. So I is now 1. Is 1 less than 5? That's true. So let's C out 1. Go back through, I++ becomes 2. 2 is less than 5, so on and so forth. So, looking at these two side by side now, we have the exact same set of code with a while loop and executed with a for loop. And you can see that the for loop just takes a whole lot less typing. And that's one of the main reasons that it exists. So in the while loop, there we are initializing the LCV, int count equals 0. In the for loop, int I equals 0 is initializing the LCV. Our test expression in the while loop is count less than 5. In the for loop, it's after the semicolon here, we have I less than 5. The body of the loop is the same. It's the cout hello end line, cout hello end line. And then we have modifying the LCV here, count plus plus, and I plus plus here. And again, I want to reiterate, these two pieces of code do the exact same thing. So, what's another reason why we'd want to use a for loop? Well, other than the fact that it is less typing, which is a good enough reason, but another very good reason is you have to put all three pieces of the loop here in the for statement. Otherwise, it won't compile. It won't let you forget to modify the LCV. In the while loop, if you forgot to put count plus plus, there's no problem with that code. That will compile, that will run, that will give you an infinite loop and crash your program. For loop is a lot better at catching these things, as long as we have a definite number that we can stop at. Okay, next. We've talked about file I/O already, but we haven't gotten into how we can read a full file from the hard drive. And we can now start to do that now that we have loops. And so in this example, I've declared a string variable line, and I have my dn, and I'm opening in.dat. So I'm just opening that file, and I'm using getLine. GetLine from dn, storing it in line. So it's stored in the variable line. And now I can say while dn. Now, why can I do that? Well, because in this example, dn evaluates to true/false. Okay, it evaluates to true if the file's found and there's data to read. It's both those things need to be true. If we run out of data because we got to the end of the file, that will evaluate to false. So it's very useful for looping through till the end of the file, right? Now, it's also false if the file is not found or there's no data left to read. So when we get in here, we can say while dn. So if we're inside the loop, we know that we got some data in line. If we didn't get any data in line, then dn would be false. So this is initializing the LCV. It's a bit more than before. It's not like just saying int I equals 0 or anything like that, but we have to open up the file and we have to read what we want to read from the file. Then our LCV is initialized, and our LCV is dn. Okay? Now the body of the loop, I'm just going to write, in this example, I'm just writing the contents of the file to the screen. So cout line and then end line. Now I read the next line. This is my modifying the LCV, is getting the next line of data. If I try to get the next line of data and there is no more data, dn will switch to false and there will be nothing in line, in our line variable. So by the time we swoop back around, we'll say while dn, well dn is false now because we're out of data. So we'll go out and we'll close the file and we'll pause the screen so that we can read the contents, and we're done. All right, so the first loop that I want to show you is just, we're going to write the loop that says hello. Let's just say 5 times. Let's say 5 times. We'll start by making a while loop. So we'll be doing int count equals 0. And then we will say So that's initializing the LCV. Then we will write our while, and we have to put our expression that while this is true, we're going to do the loop. So while count is less than 5, we will do something. We'll just write body of loop here for now. And then we are going to modify the LCV here. So we end up doing count plus plus, semicolon. So I'm going to comment this as well. This is initialize the LCV. And this is our loop test. Okay. So for the body of the loop, since I said that we're going to just say hello 5 times, we're going to see out hello. End line. And I think that's it. So this is the while loop version. Let's just test it and make sure that it works though. 1, 2, 3, 4, 5. Worked perfectly. Okay. So we have this loop. I'm going to comment this whole thing out with a multi-line comment. And I'm going to write the exact same thing, but with a for loop. So we'll start by saying for. And then the first thing that we do is we initialize the LCV. So remember, in a for loop, it's completely acceptable that we do it into I equals 0. I is not very descriptive, but everybody understands that it's a loop control variable in this context, when you're in a for loop at least. Now, while I is less than 5, that is our loop test. So we've written our initializing the LCV in our loop test. Now lastly we need to just modify the LCV. So I plus plus. So we're saying add 1 to I every single iteration of this loop. Now this is the body of loop here. So this is the only part that's the same here is we just take this, and this is the exact same thing. So let's just take that and copy and paste it. And then now we have written the for loop version of this while loop. So now let's run it and make sure that we get the exact same output. 1, 2, 3, 4, 5. Exactly like we expected. Okay. Simple loop example. Hopefully everybody got it. I'm going to pause here for just a second and let everybody copy this down if they want to or take some notes. And then we'll move on to the next example. Okay, so for this next example, what I want to do is I want to ask for some input from the user, and I'm going to take that input and I'm going to keep reading characters until we find a non-digit character, and then I'm going to tell the user how many digits in the number that they gave me. So in order to do that, let's declare a few things. First, let's declare a character that's going to be our input. And let's declare an integer that is our count. So we're going to keep track of that. So let's initialize it to 0. So we're going to start at a count of 0. Now let's see out to the user and say, please give me a number. The first non-digit will terminate the program. So I'm just going to keep reading numbers basically, and I'm going to keep counting. And as soon as you give me something that's not a digit, whether that be a space, enter, or even a letter, I want to just output what the count currently is and exit the program. So we have our LCV, really, it's input. We need to initialize our LCV. So let's do cin.get. And we're going to do input. And the reason why is because I want it to be white space aware. I want to grab, if they just put it in enter, I want to output count equals 0 and then exit. So now we need to do a while. We need to do our loop expression. Now what would our loop expression be? This is a little tricky, right? So what we're saying is we want this character to be a digit on the keyboard. So something between 0 and 9 on your keyboard. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are digit characters, right? So if I switch over really quick to my ASCII table here, this is what I handed out in class. You can find them online. this may look a little daunting, but don't be scared of it. We're just looking at the character. So this is the character column, and I come down here and I can see it's 0, then 1, then 2, all the way up through 9. So 0 is the smallest ASCII value. It's got a decimal ASCII value of 48, and then 9 has an ASCII value of 57. So what I'm trying to say is, if I put this into a logical expression, what I'm trying to say is, if the character that you gave me is greater than or equal to the 0 character and less than or equal to the 9 character, then I know that it's a digit. Okay? So let's do that. Let's say while the input is greater than or equal to the 0 character, remember, single quote, single keystroke, and the input is less than or equal to the character 9. Now, while that is true, then we know that the user did input a digit. So let's come in here, and the body of our loop is going to be that we want to increment count. So count plus plus. Let me come back up here because I'm doing a bad job of this, and I apologize, but this is initialize the LCV here. And this is our loop test. So now the last thing that we need to do is we need to modify the LCV. Now how are we going to modify the LCV? Well, basically we just got to cin.get the next input value, because the user's not done inputting characters for us. So now if I save this, let's see, the last thing that we need to do, we should output the count. So let's see out. You have input count digits. And let's just see if this works. It might not work this first time. Give me a number. I'm just going to press enter. 0 digits. Okay, that's correct. 1, 2, 3. 3 digits. That's perfect. If I do 1, 2, 3, H, 3 digits. Yep, I like that. Let's do 9, and then a space, and then enter. 9 digits. Yep. Okay, so it seems to be working just fine. So this is how I would loop through a user's input, and I hope that you can see like why I did cin.get. There's nothing wrong with doing a cin and the extraction operator, but then it wouldn't be white space sensitive, and then you would have to depend on the user entering a letter, and I think that that's a little funky, so that's why I chose that. And yeah, I'm going to leave this here for just a minute so that everybody can take down their notes that they want on this example, and then we'll move on to the next one. Okay, so for the last example that I want to do, I want to take input from a file. So I've created a data file that just has some stuff from Game of Thrones, of course, because why not? And I want to just take this, read this line by line, and output it to the screen. That's all that we're going to do with it, okay? So I need to declare an input file stream. So I'm going to say if stream. I'm going to call it dn. And remember, we always have to open our file, so we're going to do dn.open. And here I have called it, you can see I called it in.dat, so let's call it in.dat. Okay. Now before I forget to close it, I'm going to do dn.close down here, just to make sure that it's closed. So now that it's open, let's go above it and let's declare our string variable line. So that's where we're gonna read from the file, we're gonna store it in that variable, and then we'll write that variable to the screen. So first thing we need to do, we need to initialize our LCV. So we're gonna use the getLine function, and we're gonna say the source is dn, the destination is line. So we're getting a line from dn, storing it in line. This is our initialize LCV. Now, while dn, so this will evaluate, just like I said, it'll evaluate to true if the file was found and there's data, there's still data, and it'll evaluate to false if the file was not found or if there is no more data. Okay? We'll play around with this so we can see some examples of what all that means once we get this program made. So this is our loop test. Now down here, got the body of the loop. And we'll do something in a minute, but let's modify the LCV here. So what we want to do really when we're modifying the LCV is to just get another line from the file. So we could just literally copy and paste our initialized LCV, and boom, everything's all set. So now the body of the loop, what I want to do is I just want to write this to the screen. So I'm going to just see out line and end line. Okay. Now if I look at the indat, I got 6 lines with some houses from Game of Thrones and their house words, and we'll see if we get all 6 of those when I run the program. It looks like I did. Everything looks pretty good. So let's walk through this though. Let's go through step by step in the debugger and see exactly what's happening. So first things first, line contains nothing. You can see that right there. There's just empty quotes there. So if I step over after the get line, line now contains our first line from the file. House Baratheon. Ours is the Fury. Okay. Now while DN, this is going to evaluate to true now. So if I go to step over, you'll see we go into the loop. We output this first line. Okay, that first line has been written to the screen. If I open this up, you can see that it was written to the screen. Okay, great. Back to it, we're going to modify the LCV. So we get the line from DN, store it in line. Now line contains the next line of the file, House Greyjoy. Okay, going back to the top, while DN, this should still be true because we did get a line from the file. And now we write that to the screen. Perfect. Now, let's skip ahead a little bit because not much is changing here. Totally, where's the last one? Tyrell. Okay, the next one be the last one. So here, we just pulled the last line from the file. Let's see what happens. Well, when we come back through, this is still true because we did get a line from the last iteration. So we're going to write that to the screen. And then we come here and we're going to get the next line. What's going to happen? Well, when we get it, nothing happened. Line did not get overwritten. It still has the last value. Uh-oh, are we going to write that a second time? No, because DN is false now. And since it's false, it skips past the loop. We're going to close the file and exit the program, and we are done. Okay, that's all well and good. But does this really work for all situations? Like, for example, let's just say I am right now going to come in here. This is the in.dat. I'm going to take it out of the program so that it can't find the file anymore. And if it can't find the file, it can't open it. And if it can't open it, what's going to happen? Is this whole thing going to break? What's the deal? It just wrote nothing. Why is that? So if I put my breakpoint right here, let's take a look at what happens. We try to open the file. It didn't find the file, of course. We get line. Line is still empty. DN is false. We skipped right around the loop, close the file, and exit the program. That worked perfectly, actually. So that's one situation that is accounted for with this pattern of opening up the file, initializing the LCV by reading a line, while DN, C out, or whatever you're going to do, processing of that file, and then modifying the LCV by either getting the next line or just getting the next input from the file. Now, what about the case where the in.dat does exist? So, okay, I put it back, so let's run it really quick. Yep, there we go. Everything still works. Everything is still there, but there's no data. So I just removed all the data from it, so there is no data. Well, that works too. It doesn't output anything because there is nothing to output. So let's take a look at what that means. When we come in here, we open up the file. The file does exist. And then when we read a line, the line is empty. So the file, we're at the end of the file already. So while dn's going to evaluate the false. And then we're just going to go right outside the loop, close the file, and exit the program. Make sure to commit this pattern to memory for reading through an entire file. It's going to be very important and very useful for you. All right, so I've decided that we're going to do one more quick example. And this quick example, what we're going to do is we're going to take a look at how we can use loops, or a do-while loop this time. Show a quick example of that, and how we can use that to validate a user's input. So let's say that we need the user to pick a number between 1 and 4, and we don't want to accept anything else. So what I'm going to do is I'm going to declare a character for my input, and I'm going to make my do-while loop. So I'm going to do my do, and then the while, and I'm just going to put true here for now. We'll fill this in later. I'm not going to leave that as true, because otherwise that's an infinite loop. And then I'm going to see out, you have chosen input. So if we don't validate this, they can input anything, is the point. So let's see out. Please choose a number between 1 and 4. I think that's pretty clear, right? Okay, so we're asking the user to input a number between 1 and 4. And now in our, actually we want to put this in the loop, don't we? So we put that in the loop. So we're saying, okay, please choose a number between 1 and 4. See in our input. Okay, so in this loop, we are telling the user the instructions. We are getting input from them. So we're overriding what's in input. Now the while part, this is where if we go back to our ASCII chart, so the numbers between 1 and 4 are here and here. So anything less than 1 or anything greater than 4 is not something that we want the user to be able to input. So we'll use that to our advantage right now. So what we're going to do is we're going to say while input is less than the character 1, or the input is greater than the character 4. So this is saying, while this is an invalid input, I want you to loop back through and do this again. So if the user inputs a 5, this is 5 less than 1, that's false. Is 5 greater than 4, that's true. So then we'll go back through and we'll output, please choose a number between 1 and 4 again, and get the input from them again. And if they input a 5 again, they'll be stuck in this loop forever until they learn their lesson and input a proper value. And then once they choose a proper value, we'll output it back to the user to show them what they have chosen. So if we run this, let's do something valid first. Let's do 2. You have chosen 2, press any key to continue. Okay, I should put a new line there first before we move on. Okay. But that worked. Well, now let's try something that's invalid. Like, let's just say A. Oh, it asked us to do it again. 5. Okay, so we're successfully validating one character at a time. And we're asking the users to input between 1 and 4, and successfully doing that. This is a decent example of a do-while loop. Using it for user input validation, and hopefully this shows you a little bit more of, we haven't been doing any user input validation. We've just been kind of assuming that the user input is something that they meant to input, but we're getting to the point now where we can start looping them back and asking them to retry something. We can just keep retrying until the user does it correctly.